obsessed. 5, 6, 7, 8 telescopes to life.
It's not my life. It's just a preoccupation.
Want this for posterity or?
How to correct for the mirror with a paracord, why can't we just grind the mirror the right shape in the first place?
It's like erector set stuff.
Talk to you about the incredible, exciting time that we are right now in astronomy. We're in a really new age. What I'd like to talk to you about are the signposts of exoplanetary systems that we're discovering every day now, finding new systems of new planets elsewhere outside of our own. The other thing that you get from space is you're not limited by the transmission of the Earth's atmosphere, and so you have complete, unfettered access to the entire electromagnetic spectrum, including the parts outside of the visual spectrum. It's just Isaac Newton sort of discovered how sunlight or light is dispersed. When you use a prism, it sort of shows it into the different wavelengths and the different colors of light. But what was realized after that is that the electromagnetic spectrum extended even before that. Herschel was trying to understand if there was a difference in the amount of energy that different colors of light put out and measured their thermal temperature just by dispersing the light and putting thermometers across the spectrum. But when he put it in the region beyond where the human eye could see, the temperature actually still continued to climb, and he discovered infrared radiation. In parallel with the development of the Large Space Telescope in 1985, two colleagues of mine, Brad Smith and Rich Terrell, used a telescope at Las Campanas Observatory in the southern hemisphere, a 2.5-meter telescope, equipped with a coronagraph, in order to try to photograph one of these pictures. The coronagraph blocks the light of the star, and what they saw was this discovery photograph of not a shell of gas, but what looked like a disk edge on. And this was the very first photograph of an extrasolar planetary disk around another star. Why observe in the near infrared? Well, again, the real reason was not originally so much for planetary astronomy, but the main reason is we can see in places in the near infrared part of the spectrum that we can't see any of the visible or ultraviolet light. And the main reason for that is that dust clouds that are prevalent in the universe, nearby, far away, they absorb optical light, but infrared light can penetrate through the dust in the universe, and we can see through these dust clouds into the birthplaces of planets, where planets are being formed in other systems, and birthplaces of stars and galaxies. We can see the centers of the most powerful galaxies by cutting through the dust in the infrared that we can't do at other wavelengths. Near-infrared light really penetrates dust, and that's the real power of near-infrared. Also, as you go along the wavelength, the objects that we see as they're moving further away, the universe is expanding, the most distant objects, the wavelength of light shifts more and more into longer wavelengths. The faster they're moving away, the farther they're moving away. So in the near-infrared, we actually can see further away and into the more distant past than we can in the optical. This is why they wanted definitely to have an infrared telescope.
The sky is spectacular and getting better by the second. I hope everybody's going to...
Are you gonna make it? All right.